Many years ago, when people wanted to look at the stars, they used one of these, a telescope with lots of lenses in it. Astronomers don't just use lenses though, they use specially curved mirrors, a bit like this one. But why? I think an investigation is in order. So I've come to see astronomer Dr. Sue Warswick, who, with the help of 2 parallel lasers, is going to show me why mirrors are so useful.
The mirror we have here is curved inwards and it's called a concave mirror.
So what can a concave mirror do?
Well, if you look here, we have the laser light coming in. You can see it's reflected inwards and is being brought together. If I move this card along the light beam, you'll see that the light crosses over and in fact then is upside down.
And that's what's happening when Stella looks at the inside of her spoon. The image she was looking at was upside down, because the inside of the spoon is a concave mirror, and the light rays from her face have been turned upside down, so that the top becomes bottom and the bottom becomes top.
But the point we're really interested in is when we get to this place here, where all the light is concentrated together in one spot.
Now, how can you use a mirror that concentrates light in astronomy?
Well, if we go out into the lobby, I can show you an example.
So, Sue, why have you brought us here?
Well, Femi, can you see the map on the wall over there and all the countries in it?
Well, I can see the map, but not that much detail. It's a little bit far away for that.
OK, well, this is where our concave mirrors start to come into action. The one we have behind us here is like a bigger version of what we saw in the laboratory. And the light coming from that map is concentrated by that mirror. And if I hold this card up, what can you see?
A small image of the map over there. And where the image of the map is sharpest is where the reflected light rays cross over, just like in the lab. It's very bright considering the light's travelled all the way over here and it's been reflected.
Yes, and if you look with this magnifying glass, you can see that all the detail is there as well. Now this is where our mirror is coming into its own. We have bigger mirrors than this in telescopes, and they produce images not of a map 10 meters away, but of stars and planets that are millions and millions of kilometers away.
So next time you're looking at the concave mirror in your bathroom, just think of the 8-meter wide versions that are looking into deep space.